We'll help you. We'll be here for you. You can do just the screen or just the app. It's just like any of those other ones.
Anybody not muted, go mute.
Yeah, I'm going mute. We can also look you guys up and mute you ourselves if we need to, but it was probably me. All right, yeah, I'm going on mute.
All right, we're going to see if that worked. You should see Google slides over here.
I see your slides.
Just out of curiosity, I'm going to jump because I have it open in a couple of tabs. Do you see one? Do you see a second one here? Configuration management now?
Yes.
Okay.
Yep. You
Perfect.
did the whole screen. That's good. That's what you want. Or maybe you did just the app, but either way, we can see it. Yes.
Yep. All right. And last check. Can you see the slideshow now?
Yes. Hey, I have
Perfect.
one thing to add real quick. You can watch the chat, or if that's going to be too distracting for you, I can just, when people ask questions, I'll make a duck noise if that's okay. I don't know if you can see. There's a chat component to this. Okay.
Yeah, that's fine.
Right.
I got two screens here. I can see the chat, but I don't mind the duck reminding me that I got something, so I can look over there.
Okay, I'll just do it sparingly. It's all you.
Sure. All right. Well, hello everybody. Thanks for having me here. My name's Robbie Reed. Scott asked me a little while back to give a presentation on just my background, and then he convinced me to get back here and talk about something else. I'm a DevOps engineer, DevOps lead for the company I work for. I'm also the director of programs at my company and taking on some other leadership roles. So that's been an interesting journey into some more leadership side, but I'm still very much, I like to think of myself as an engineer most days. And I've been working, DevOps, it wasn't necessarily called that, but I've been working integration software deployment for about 15 years. And I've been a software engineer for about a little over 20 years now. So I've done a lot of web development in the past, but that led me down the integration path. And I just really have enjoyed that. Spent a lot of my time, and like I said, 15 years doing integration from the software side. So the process that was actually developed by a mentor of mine was this word salad, right? Or this alphabet soup, CMBP, DIDICO. And I'll get into that, but that it really came about around the same time that the DevOps constructs came about, and me and others tried to convince this guy's like, you gotta go patent this. This is really novel. And he's like, yeah, whatever. It gets the job done. So, but it really has been very helpful to think about this. So, so DevOps, just to give you an idea of my perspective on these, I have here, DevOps are the principles of efficient automated mechanisms to bring a developed system into production. It doesn't necessarily mean you're using any one particular technology, and that's the case with most of what I'm going to be talking about today. Continuous integration, continuous delivery, or continuous deployment, depending on what your definition is here, but this is more about the automation of the DevOps process, and in general, I prefer this term over just DevOps, though you generally need to be talking to engineers for them to know what you're talking about with CI/CD. But like I said, it has to do more with making sure things are automatic, getting into your baseline, that tests are run, that packages are built, all those things. But what I dislike about CI/CD, not the process, but the name, and I'm certainly biased, is it doesn't really tell you all that there is to it. It is about automation. It's about continuous delivery. But the process that I've used over the last 15 years is the CMBP DIDICO acronym, and it is just a repeatable process framework to bring software into service. And I did say I was going to turn this into a monster truck slideshow. That it's admittedly not a monster truck, but that was the site today was Robosaurus eating, I think that's a Dodge Neon. or something. It was excellent. So I was trying to come up with some sort of analogy for Robosaurus to this process, and I didn't have time. So if you think of one, you got plenty of time to share. But anyway, that was my day earlier today. So you've been dying to know what this acronym actually means. We didn't even take the time to make it a backronym. It's like it's unpronounceable. People have tried and failed, and there was much weeping and gnashing of teeth while trying to determine how to pronounce this thing. But here it is. So CM is configuration management, B is build, P package, D distribute, I install, D deploy, and ICO is initial checkout. These are really the steps that are involved in any CI/CD pipeline. That's really what this is about. This isn't like a different CI/CD or different DevOps. This is just how I think of automated development, automated deployment of software and systems. And it's frankly, when I see processes, when I'm reading about CI/CD, my brain puts each step that they're talking about into these categories. And the reason is, depending on how you're building your software, there's a process that you want to work through. You're not going to, or you don't want to go install your software before it's managed in source control. You certainly can't check it out until it's deployed and running. So there's a process here, but it's not strictly linear, particularly as we build systems. Oh, I skipped my 1 or 2 sentences on CI/CD. Let me go back to that. I apologize. I was excited to get to Robosaurus. So I had here just the title, Continuous Integration, Continuous Delivery of a Software Baseline into Production. But to dive into it a step further, it's about tying together your source code, when you deliver that to master, when you deliver it to the branch you intend to deploy, there is an automated process to test it, verify it, and get it into a running environment, which hopefully isn't straight into operations immediately, based off of events in recent weeks. You don't like seeing your software get deployed to millions of computers and then it doesn't work, but that there's an automated process to take it to a point that you can then verify it and then slow roll it out to additional resources. But it's about automation. So from source code to production. So jumping into configuration management, what do I mean by configuration management? You might hear it called a couple of different things. You could hear software configuration management, you could hear version control, source control. Anymore, what that generally means is Git. And I'll dive into that. So, but it's the process of establishing consistency through the software lifecycle. Let me see. I see Salty had a question there, or your statement. Yes, that's right. That's exactly right. And actually, to that point, it is about automation, and it's not necessarily about merging code into master. It could be based off of ticketing systems. There are some that would wait for, say, your Jira ticket for you to say, yeah, deploy this now. But there's all kinds of ways to do that. So here, why do we care about configuration management? Right, it's the capability to recreate a specific software version in any development or deployment location. You don't want to get into a situation where you're experiencing a bug and you don't know how to recreate it. Right, many times bugs are dependent on the environment they're running, probably most of the time. Otherwise, the bug probably wouldn't have occurred if you're being somewhat diligent with testing and things. That you just can't you can't recreate all of those specific combinations. So when someone says, hey, I'm running this software, this version with this and this and this, you need to be able to go back and recreate those. So these slides, by the way, come from a training course I did for my company. And so you'll see a lot of references to Jenkins. That is what we used at the time. And we still do, but we also use GitLab runners. This somewhat focuses on the Jenkins side. So Jenkins is a DevOps or an integration tool. It allows you to set up automations, pipelines, triggers. You can email people results. It's a pretty useful tool. I'm partial to it. I've been using it a long time, but GitLab runners are excellent too. We've really been diving into those. They've been very good. But anyway, so Jenkins integrates with your tools, allows for simple transition of source code and software to each step. So in general, I'm talking about source code, but that's actually not the only configuration management that you need to keep track of. Source code's important if you're writing code, that's obvious, but as you build the software, it needs somewhere to go, and you want to keep track of your built software. That you can use tools like Nexus, or there's Artifactory, or maybe you're just using S3 to store libraries. Lots of different ways to do that. But you need to store libraries, containers, or VM images, and then you have documentation. Scott talked a lot about documentation earlier. That needs to be in a location that is managed, because the documentation for how you run this software today is going to be different than it will be a month from now when you change that interface. And so you need to be able to go back and not only, if I'm running version 1.0 of the software, I need the documentation for version 1.0. So those need to be tied together. So a little background on, I've dove a little bit into Git in case you're not familiar with it. Especially if you're not a software engineer, you may not be familiar with it, but it's a distributed software configuration management tool. It was created by the same dude who created Linux, which, by the way, Linus Torvalds has said he likes to name things after himself, and so that's why Linux is called Linux, and that's why Git is called Git. And if you are familiar with the slang in the UK, Git means stupid, but it's the stupid source control system, and it's simple. So he said a lot of people call him a dumb Git. So that's named after him. He named it himself after himself. So source code is organized into repositories, and repositories are managed by master origin server on the clients. They're grouped into commits and chained into branches so that you can recreate all of your software changes forever. As long as you're committing your code, it's always going to be recoverable. So if you committed on Monday, and then you committed on Wednesday, and you committed on Thursday, and you're like, ah, crap, I screwed this code up, I need to get back to Monday, it's easy. You grab the commit for Monday. It's right there. It will never be lost. And I may cover this later, I don't recall, but those commits are what's called immutable, never changeable. Once they're there, they're there. If you want to make a change to your code and then you want to make a change back, you don't delete a commit. I mean, that's technically possible if you haven't actually merged it, pushed it into a baseline, but in general, like I said, if you've committed merged from Monday and you want to go back to Monday, you actually have to recreate that change and recommit it in order to get back. But that history is always trackable. So you can say, yep, I made the change Monday, made the change Wednesday, made it Thursday. Oh, it's Saturday. I got to go back to Mondays, but you can see those changes. And so this is just an example of how you might split up your Git repositories. Maybe you've got a backend server, you have a REST client to talk to it, and you have a web server. You may split these up into 3 separate repositories for easy tracking. There are a lot of philosophies on this. I'm not going to dive into depth on why you might choose one or the other. Some people for related repos, they want one repository because the versions are combined. I mean, I'm happy to answer questions. I won't say that I've got a strong opinion on it because I think there's a lot of value. It depends on the use case. I tend to like to split out repositories, but I'm working on a program right now where the number of repositories was becoming unmanageable and the versions were really important to match. And so it made a lot more sense to have one master, one main repository. I'm looking at the picture here, the original Git meaning. Yeah. Yeah, stupid, contemptible. Yep. So what belongs in Git or any source control? Code, scripts, config files, API documentation, that kind of stuff. The question, should I CM this file? The answer is yes. No, the answer is no. to Scott, don't CM your AWS keys. There's always the smart aleck in the group. Secrets, there are better ways to keep track of those. All right, you got me. But if it's compiled or generated, I'll count those AWS keys as generated. So there. Don't CM those files. Those are regenerable. Is that a word? Regeneratable. And yeah, make
yes.
Yeah, make the repo public after storing your secrets. Do not do that. Don't store secrets. Don't store passwords in there. There are better ways to store those things, but I'll consider those generated things. But you may have your configuration on how to retrieve that. Like maybe you have a secure way to retrieve certificates or keys. Yeah. Anyway, yeah. So branching. Best ways to manage secrets in a CI/CD context. You know, that's been a constant issue. In fact, we use SSL certificates in our system for a lot of communication, but those have a lot of problems in that they expire. So if you have a long-running system, then you need to keep track of certificates. And we got a question. I'll throw it out there. Scott, are we recording?
I'm not recording, so I think you should be fine.
Oh, no. There was a question from the chat. I'm not going to say anything that I'm concerned about recording, but someone was asking if it's being recorded.
We're not recording right now, but I will make it a deal that for people that want to, because I know like Michael Pessa, they wanted him to. Robbie, maybe I'll get you on sometime when I'm streaming, and then that'll just be recorded, and then we'll carve that down if that's okay.
Yeah, I'm happy to do that.
This will be your practice run with everybody, and we'll do another real one later.
Yeah, sounds great. All right, so branching. Branching is an important feature, for lack of a better term, in source control to be able to keep track of changes. So you want to make a change to the source code, but you need to group a bunch of changes together. You can make a branch, and sometimes they'll be referred to as feature branches. But a statement I heard, and I forget who said it, so I don't have it attributed to them, but if I knew it, I would put it, these are not my words, that master is or should be the most interesting branch. Master needs to be the thing that you care about. You should not have a feature branch that you're deploying into operations. Feature branches are meant to build some functionality and put it back in, or by some people's opinion, maybe don't branch at all, and your quote unquote branch is really just your local master copy, and then you rely on your CI/CD processes, your CMB, PDA, DICO processes to vet your changes before they get deployed. And that comes down to team preferences. I, at this point in my career, prefer feature branches, but short-lived, like a day, if that. I'll merge branches in like hours or minutes sometimes once they pass tests and such. Yeah, so I forgot I had this slide here. Yeah, so they should exist for as short as a time as possible. The longer it's divergent, the harder it is to merge. I have spent days merging software branches because people have had them for months, like literal months, where they've diverged the baseline and now they need their code to work. And code merging at that point is relatively simple. I mean, it's difficult to merge code, but it's not about merging the code. Like, you can make it compile. It's about the functionality. Like, how do I know what your code is doing, especially if it's not documented well, which it usually isn't if it's been developed over months in a divergent branch. So, yeah, lots of experience, or at least some experience with merging. Yeah. And so the last line, merging is the enemy. The reason you want short-lived branches is because you want zero merge conflicts. You want to make your change, put it in master, and you want it to say, yep, you're good. No merge conflicts. And what that means is there is no other code that was changed underneath you while you were off in this separate branch. Now, that doesn't save you from functionality merging. You could still have somebody change some adjacent function or maybe a dependent function that you didn't actually touch, but it affected your code. And that's where you need to rely on unit testing, which we'll get into, to make sure that your code is still good. And so a quick maybe helper slide on things you should know for Git. These are things I use every day when I'm coding in Git. There's a lot more to get in the nuances of these commands.
Robbie, can I say something real quick?
Yeah, go ahead.
I was going to point out the way you said that, the things you need to know for Git is kind of funny. I heard that out of the corner of my head. Yeah, the things you need to know for Git.
Yeah, forget it. Know for the software control system Git.
There we go.
Yeah, so there it is. You can screenshot it or whatever. I'm not going to go over each one, but those are some useful commands. There's lots of tools out there to tell you what you could use there. I talked about immutable commits. History integrity is important, and I think this is interesting because I'm a nerd, but I'm pretty sure I'm talking to a room of them, so that's great. The history integrity is cryptographically secure hash chaining, which if you are familiar with it, that's what blockchain is. Blockchain has been, much more the hotness recently, although I guess Bitcoin's really been around for like 14 years now. But technically the Git history is a blockchain for all intents and purposes there. It is a collection of changes based off of, it's a hash of the changes built off of the previous changes with hashes. The history, the integrity is important. Salty asked the question there. Back to configuration control, it can be for the aspect of finding bugs. It can be for security purposes. Somebody could, if you didn't have if you didn't have a reliable history, somebody could maybe slip in changes that you don't realize. It could affect merges when you have to do them, that they're not, they could be out of order. It's very important that the history of your code has integrity. Another very well, so the XZ thing, that wasn't anybody like slipping code in outside of the chain. That was a malicious actor or a set of malicious actors convincing the individual running the project that they are trustworthy, and then slipped in malicious code. So another neat thing about Git, I said this earlier, that it's a distributed source control system. Everybody who has the repository, as long as they're doing a Git pull and they're staying up to date, they have the entire history. So if your master server crashes and no longer exists, like the hard drive just went up in dust, or maybe there's a fire in your data center or something like that, everybody who has that repository has the entire history of the code, and it's recoverable. This has actually saved us before. We had somebody accidentally delete our Git master VM, and it was really no big deal. We just said, okay, they'll come back and we'll get that VM back online, and we'll just push our repos back. We had no data loss because it was just naturally distributed. And then, of course, that person made sure that we had backups of that VM. All right, give me 1 second. My dog says he wants out. I don't have a Ranger cam, so you can't see that. I'll be right here. Right back. 1 second. Sorry.
That's fine. We'll just hang out and dream up questions we want to ask you. Make sure you guys ask Robbie questions, because he actually sounds like he knows what he's talking about, not like me or the other guys.
I sure do. I can sound like it. We talked about that earlier. It's the deep voice and the height. All right. So into building and packaging. So I've also in parentheses put unit tests. That's something that from the start of this this process, when it was developed, that it included unit testing, but for whatever reason it wasn't called out in the acronym. And technically unit testing is done in the coding side, and we'll talk a little bit about that too. But to me, I treat it as part of the build. We'll talk about that here. So process of creating a collection of compiled functional distributable software that can be traced back to a specific code baseline. Did we have a question that I missed here? How the backup restoration process worked? Oh yeah, for the Git server. Yeah, so what happened, well, I don't know how it happened, but somebody just straight up deleted the VM. We didn't have any backup of that VM. It was gone. The data, everything that was in that VM was gone. So somebody actually spun up a new VM, started a Git master server again. I think it probably had the same DNS name. So we all just did a Git push, and we probably had to clear our SSL public keys or something for the server, and it just pushed it all back. Salty, yeah, I'm a DevOps lead for a couple of our programs. Yeah. IceQ4, what do you mean in project history over viewability? I'll let you type that up. I'll go a little bit further here and I'll get back to you. So some tools for building, it really comes down to the language you're developing in or the team that you're on. There's so many tools out there. We've used Maven for Java, Make for everything, Gradle's also Java, GCC for C, C++, unit testing, lots of frameworks out there, packaging. Also, depending on what you're developing, the packaging tools are going to be different. Lots of things out there. The build traceability, we talked about this with source control. You want to be able to get your code all the way back to the code. You want to follow this through the whole process. Your whether it's a commit hash or a timestamp or or something that is meaningful to your code base should make its way through this process, and that includes in your builds. Your commit should have a build ID, or your build artifact should have a commit ID. You know, like you should be able to tie them together. I can't tell you exactly which to use because it depends on the tools you're using, but what we've done is we've used the commit hash timestamp in our build packages. That's worked pretty well for us. It helps us trace that all the way back to the source code. It's what's worked. You can use commit IDs too. They're just harder to read. A timestamp's nice because that came from July 1st. Oh, so you're asking like if I Q4, if you want to reorganize a repository, is it worth doing that and then losing the history, whether that's a new repo or in doing the reorganization, you really lose the usability of the history. I would much more value the structure of the current repo over the history of the repo. History is maybe important if you're keeping track of multiple versions and have to deal with bugs, but the current repo is what you're using. You want it to be useful, and especially if you're working on a team, it's got to be something people can comprehend. So that would be much more important. But history is important, but not. I wouldn't say no. Don't reorganize that. I want to know what I did in December. No. So a unit test. The unit test is an extremely fast test that exercises a single path through a library. I want to emphasize that. A unit test is extremely fast. I think I call this out here. It should be like less than 10 milliseconds per test. It's going to be one function. I say a single path through a library, and it really should be a single step through a single path through a library. You're testing that when I pass an A and B, the result, if it's a summation function, that it adds A and B. You're not writing a unit test that tests your entire software suite and along the way making sure that function gets A and B. No, I'm testing that function, that A plus B equals the answer I expect. And you'll pass it a lot of different iterations of that. You might have 100 tests of that function to make sure that it's good. But if you have 100 tests that take, even if they took 10 milliseconds a piece, that's anybody want to do the math on that one? You took longer than the answer. It's 1 second. So that would be great. You got 100 tests to run in a second. I'll run that all the time. You can use tools or write tools that run your unit tests as you save changes to that, and you want those to be very quick. This last bullet, test-driven development. I've got another slide deck that I will include in here too. I will probably have time to get to it, but that's about writing your tests first and then writing your code. It's an interesting, useful concept. I like it a lot. It helps you design things better. We'll dive into that more later, but it's unit tests are important, and they ensure the integrity of your software. The underpinnings of a lot of CI/CD and this process rely on unit tests and other types of tests to ensure that your code's working. Modern languages with built-in unit testing. Honestly, I'm trying to think. Does Python's unit testing I guess it's kind of built in. Having a unit test framework is important. Whether it's built in, okay. I'm not as familiar with Go and Rust. Having it built in versus having another library, I would say probably doesn't matter all that much, except for the fact that in this wide world of engineering, you're going to have people that'll complain if you have to install a library to do unit testing. So there's that advantage. I could buy into that. But get a unit test library. There's lots out there, and or use a language with it built in. I got nothing against Go or and Rust at all. Those are great languages. So I said this earlier that builds, I treat unit tests like they're part of the build, because a build shouldn't be viable if your unit tests don't pass. One of my pet peeves is when people try to seek like waivers in our build processes that their unit tests don't pass. So, but they know their code works. So let's move it forward. It's like, oh, hold up there. No. This has got to be fixed. There's a reason those unit tests are there. And I mean, sometimes unit tests are written poorly. And we'll talk about that a little bit, the test-driven design, test-driven development piece. But generally they're there because somebody had something that should be tested and we should fix those. And sometimes the results of the code change, and it can be hard to tell if the test is bad or the code is bad. And that's, I think, a lot of times when people get frustrated with the tests, because it seems like it's unclear whether one or the other is wrong. But ultimately, if build doesn't pass unit test, or if a build doesn't pass unit tests, it will not be distributed, which is the next step there after the packaging. And depending on the code you're using, this is where it gets a little bit hazy. Depending on the language you're using, you might need a package before you do a unit test. Maybe not, depending on the utilities. Like if you're using Maven to build Java code, it wants to build and package the Java code before it unit tests it, which is no big deal. We're not going to distribute it. And I talked about this a little bit. Traceability, we use the git commit timestamp. That has just been the most useful for us. If you wanted to get down to like the most cryptographically secure or like the absolutely secure, then you would use a commit hash. Sleeping Turtle, you call out a full test suite. I will get to that. I agree. But at this point, I would disagree. And the unit test is all we want to pass right here. So, and that really comes down to an initial checkout, and that can be a variety of things. We'll get into that. Build automation, I think we talked a little bit about this earlier with tools, but use a build automation tool. Please don't write your own scripts. I've seen it. Like the closest to writing your own scripts is probably something like using make and makefiles. That at least has some structure to it. But again, it depends on the language you're using. I've used a lot of Maven, a tiny bit of Gradle, a lot of Ant. Unfortunately, it's really been replaced by others. But there's other tools out there. And then you want to look for a build tool that integrates with your artifact repositories for distribution. So that's just a consideration when you're looking at that. Here, we'll take a quick vote. I guess I've got like
you got
50
time.
minutes. I got time. Yeah, I was wondering if I should save TDD for the end or just dive into it. Maybe I'll just dive into it.
They're all yours. They're not going nowhere. Wait, do you want me to tell you my favorite thing about that presentation from something you said to me like 15 years ago, or do you want to say?
No, go for it.
You came to teach at ITT Tech, if you recall, for a little bit. And one day you walked into my class and you looked up at my board and I had a really, really white like presentation that was very vanilla. And you go, "Oh, Scott, come on, man. That's so basic." And I was looking at these and they're so white and so basic. And I'm like, he's making it work though.
I'm glad you called that out because I was going to say something. No, I was going to say it because I'm like, I think I'm different from a lot of people in that I don't like dark mode. So I might have just turned like everybody off in this discussion. Yeah, see, So yeah, I'm sorry, my slides don't have a dark mode. I prefer the light background and dark text, but I've got I got little icons in there, spice it up a little bit.
Fair enough.
I will accept that I'm not a cool presenter. I'm a dad with 4 kids, so I long have accepted that. So, all right. So diving into, did I do that whole previous presentation not actually in slideshow mode? I just realized I don't know if that actually went into it.
That's okay. Fine. That's all fine.
So TDD, you can see I've got CMB, PDID, ICO crossed out because this is actually a development paradigm that I am a fan of. I try to do, but I can't say that I'm like a zealot and like this is the way that development is done. But when I use it, it is very useful, and I encourage my engineers to use this. So we already went over this. Again, these are slides that I presented to my team, and so over courses of weeks, which is why there's separate presentations here. But just to recap, in case you forgot 30 seconds ago, extremely fast. A unit test is extremely fast, should run in less than 10 milliseconds. But I'll throw this out there. Question break. What came first? The first unit test framework, or also I'll say that the description, like the educational or the academic paper on unit testing, or Python? Like PyTest came before Python. the true TDD. I'll give 5 more seconds. It's closer than you think. So the first unit test framework actually was written about and started to be developed in 1989. The SUnit actual tool called that, I think, was actually quite a amount of time after that point. But Kent Beck released that 89, and Python was released in 91. Did you guys know Python was 33 years old? People, in my mind, yeah, in my mind, Python's like the new hotness that all the young kids want to use. But it's like, it's been around for 33 years. I mean, it's still very popular, and it really, the introduction of some of the like machine learning libraries in Python really are what drove it over the last 10 years or so. But yeah, so Kent Beck also wrote JUnit, I believe, which is like it is the Java unit testing framework. So he's a big name in that world. And I think he's a part of it's like X programming or extreme programming organization. Anyway. Yeah, Java is actually younger than Python. Java was from like the mid 90s, maybe 95. You can check me on that one. I won't claim that as actual knowledge, but I'm pretty sure Java was like 95. It's true. So TDD, development process that emphasizes testing first. You write a test, then you make it pass, which sounds counterintuitive, but it's actually very useful. So you're writing some code that you want to see if and you want to write a function that adds A and B together. You write a test first that says, well, when I pass in 2 and 3, I get 5 out. And so you write that test, and then you write the code that allows you to write a function that's all it does. For those that aren't software engineers, you might, or developers, or haven't coded, you may not realize there's thousands of ways you can write code. If you're writing a script that takes in 2 numbers and then outputs back to standard out the answer, you could just write a main function that checks your arguments and adds them together and spits them back out. but that code isn't very reusable at that point. Like maybe you have another script that calls that script that parses the output, but you probably would want to write a function that does that. And then that script can still do pretty much that basic piece, but then you have a function that could be used elsewhere. Well, what if you write your test and you're the one that wrote the test and you're the one that wrote the code. So to pass the test, you could just make the code return 5, right? You wrote the test that says add 2 and 3. Your function could just return 5. It could, in fact, that's the principle behind that, is be a little sneaky in your code and do the least amount of work to make that test pass. And so you're going to write, okay, 2 plus 3 equals 5. Yeah, that function gave me 5. But now what if I pass 3 and 4? If I write a test that checks 3 and 4, you're going to say, oh, 7 doesn't equal 5. Why did that function return 5? Well, you told it to only return 5. So now you need to do some work to make it return 7. And then, you want to write the most efficient code to do that. You could do something really dumb and like start writing if statements. Well, if I passed in 3 and if I passed in 4, then return 5. But hopefully somebody will slap you over the head and go, just add the numbers together. And, but then you say, okay, I added them together. Now, what if I pass in the letter A? What happens if I try to add A and 3? What do I get? And depending on the language, depending on how it handles that, maybe it took it in as hex, and you're adding the hex value of A to 3, or I don't even know at that point. It really depends. But that's where you need to start getting into that. Maybe you do that and it throws an error. Throws an exception. Okay, well, actually, I want my function to handle that. I want to have some error handling in my function. And so then you can write the unit test to actually say, when I pass in A plus 3, it should say the ID10T exception. And it'll say, hey, dummy, don't pass letters to an addition function. Anyway, back to the slides here. TDD strengthens CMVP process. It improves the trustworthiness of the packaging. That's unit testing in general, but TDD, it makes for better development, in my opinion. So I got ahead of myself. Write your unit test, prove that it fails, write your code, prove that it passes, and then write another test as you go, hey, I've got a way that I could break that code. And you just keep doing it until you're satisfied with your function. A really interesting development principle I've heard is to set 2 developers together. And I've done this a little bit, but I haven't got to really take it to its full potential, is have one person write the code and one person write the unit test, and really let the unit test person be a troll, right? Let them break that code. And this can be important when you're writing critical systems, especially if they're like, life important to people's life. If it's a aeronautic control system or a medical system like this, that's where it really becomes important to make sure these things are tested well. So being able to set 2 people on it, so one person's writing code, one person's writing tests, and then you swap roles as you go. It's just a philosophy that's an interesting approach there. TDD doesn't replace software design. You still need to get to a whiteboard, go write it up on a wiki, go make a draw IO diagram, whatever it takes to design what you really want your code to do. And then you go through the development process. TDD is not integration or enterprise testing. Those have their places, but we've made this mistake on a program I was on. Don't go try to write system tests before you've written the code. Like, you can write requirements, but it gets really difficult to write system tests first when you're talking about interfacing and things like that. It is important to design those first, but the nuances of how interfaces talk to one another, they really need to be developed first. So that can be part of the design, but it gets a little squirrely. Um, step 2 sounds like hacking. Exactly. Yeah. And it is Scoot, by the way, just to be sure. The TDD doesn't demand 100% code coverage. So like if you're writing, if you're writing an if statement that, maybe if you pass in zero, if you pass a 0 to the addition or a negative, it prints out, a string that says, hey, by the way, I'm adding negatives. But yeah, I don't care. We don't need to test that it prints the string out. That's not critical to the requirements of our code. I just wanted to do that. Maybe you don't write a TDD or you don't write a unit test to do that, and that's okay. Oh, I left this slide in just as an example. This was, I don't actually have the test to show here, unfortunately, so I apologize. This was a fun tool I got to build. This is a WeatherSat, the NOAA, I think this was NOAA 18. You can actually just receive these signals from space. This isn't one that I personally received, though I have done some of it using software-defined radio and receiving. But this was somebody, I think, in Germany that received this signal from the satellite. And the 2 on the left are the actual signal received. It comes down in this line. It's called a line scanner. And you receive each line as the satellite travels across the surface there. And I believe the image on the left is a near visible infrared signal. So it's like almost colors you can see, but it's infrared. And then the middle image there is called far infrared, and it has much more to do with the temperature of the thing that's being imaged. And those are useful on their own, but you can actually combine those two together to build what's called false color imagery. And so the image on the right, it did not come from the satellite like that. That's the combination of those 2 images into using a color map to determine what's clouds, what's ocean, what's arid desert, what are tree covered areas. But I used TDD to develop this tool because I knew, well, I know that if I'm gonna have these parameters for these 2 infrared spectrums, I needed particular results to come out the other side, and I was able to use the process to build this up. It worked very well. I actually contributed some of this back to a GitHub repo. Actually, sorry, not the false color piece. There was some other piece to this, but anyway, sorry, that was an aside. But yeah, this is code from our company. I wasn't quite ready to go sharing that out, but it's just an example where I was able to use TDD and get some good results here. So I got into this a little bit. Can it be used at a higher level, like system test-driven development? And I would say probably not. There are some really great tools. We use behavior-driven development. I like it a lot. It helps you write system tests in a way that you can like write English language. Yeah, we use Gherkin. I mean, it's the Gherkin syntax. If given, when, then, and all that. I don't know why it's called Gherkin. I don't really know what that really means. Honestly, I've never thought about looking into it, but it's just a way of describing a test. So you say, given my server's online, when I hit the endpoint that adds 2 numbers together, then, or when I hit the endpoint that adds 3 and 4 together, then I get the answer 7. And very useful, very powerful. I've actually used But BDDs, we'll get into ICO. BDDs are a great ICO tool. You may not only use BDDs, but they're a way to verify that your software, your system is ready to go. And we do use it that way on my main program that I support. Our software has to pass this test, this suite of tests before it ever gets sent out the door. That's all the way back to an earlier comment that was made that, yeah, system tests, automated integration tests, all that stuff, those are part of our BDDs. I do have this TDD for beginners. I think this was by, oh my gosh, I'm totally drawing a blank on his name, but he does continuous integration, I think is his channel. I probably got that wrong. Dave Farley, that's his name. Lots of great stuff from him. Oh, we talked about this earlier. Build traceability still goes to tests as well. I won't dive too much further. We talked about this earlier with tag commits, all that kind of stuff. And then, yep, use your builds as a part, or your unit tests as part of your build. Make sure they're passing. And I didn't really say this earlier, but development is like the kind of before the CM part. I'm talking about like taking your code all the way to the end. So the unit testing and building are those things that are going into CM. They're getting built, and then your unit tests aren't necessarily getting packaged, but they're the thing that validate whether it should go beyond the build phase. Was there a question that I missed there? Let's see. Pipeline return the result of the test run. Yeah. So our Jenkins pipelines do return the results. They'll display them. In fact, ours are integrated with, depending on where we're doing development, GitLab or Bitbucket, and they'll run when we put up pull requests, merge requests, whatever the tool is, and we're supposed to not merge it until you have passing unit tests, but it will report it. It'll say your unit tests are not passing in there. Oh, the question I missed was, Scott, you were saying that I do consulting. Yeah, no, I'm not a psychiatrist. No matter how soothing my voice is.
You got a question about what industry you're in?
Oh, I am in the defense industry. I work primarily with systems that do SAR. It's called synthetic aperture radar, where you can create pictures from radar signals. It's been cool stuff. All right. Quick recap, CMBP, right? That's configuration management build package. These were test questions for my engineers when I was doing this, because it was over weeks. Distribute, install, deploy. Did I no, we didn't chat about any of this stuff yet. So great. So distributing is about placing the software packages in accessible locations to your target environment. So what does that mean? That's like putting a jar file on S3 if that's how you need to be able to get to it later, or probably more accurately, you're going to go put it in Nexus or Artifactory. Then your installation is about actually landing that software on the host or the location that it's going to run. So that needs to be, and that needs to be present. You're not running it yet. We're just putting the software somewhere. So that's like doing an RPM install on a Linux system. You haven't actually placed it. You haven't started the software, added it to your initd or systemctl. It's just there. You just did an install. But the deploy is about actually starting the software. It's about making sure it's in its place to start when the system starts, or just when you run a command or whatever that looks like, that the software is now running. And I put here the DID is really the ops part of DevOps when you're talking about getting into your operational environment. Like, it's past all of these steps. I'm now going to go deploy it into operations. But I'll talk a little bit about how this sort of loops back. But yeah, that's where when we talk about installing software, usually we mean all three of these things. Oh, I thought I took this question out of there. I think I said this earlier, but just take a guess on when DevOps. Yeah, when was DevOps introduced? And I did say this earlier. We started using this acronym in like 2009. And we didn't know it was called DevOps or anything like that. We just thought it was a useful tool. So if you're all Googling DevOps, trick question, I have no idea. DevOps started being a thing in 2009. That's when the early documentation is out there. People starting to call it that. I'm sure it was one of those cases where it's just where the environment, the development world was going, and the person that came up with this acronym was like, oh yeah, I can see that's where the world's going to. So he was right there with it. Yeah. So software distribution, there are lots of tools out there. Again, it really depends on the language you're working in, the tools you're using, the packaging you're using. But Nexus they call themselves an artifact repository. That includes Docker registries and things like that, but Docker, it has its own registry. Pip is an installer, but again, it's pulling software from Nexus or from other repositories. And then Yum, or it's really DNF now, right? Showing my age. I think Yum is still aliased to DNF. Yeah. So people like me can
not the most recent install of Fedora.
Yeah. That I will not be using that distro. Not if I can't type Yum. No, not really. So simple example, you probably will have a server that's you're doing your desktop, whatever it is that you're building and packaging your software. You're going to put it out there at a distribution point onto maybe a Nexus server or a hosted service out there. And then where your software is actually going to run, you're going to go onto that host, and you're going to do a Yum install and actually start the software. And so here you can see that these steps actually exist at different places. Your build, package, and distribute could be on one host potentially, but you're probably distributing the software out to another host. And so the software is about a deployment across systems. But maybe more likely, if you're developing on a larger team for a larger system, your software is going to land on multiple hosts. Maybe it's dozens or hundreds or thousands of hosts. So you need to think about that when you're deciding how you're going to distribute your software. We're running into issues right now where the third-party provider for our Docker registry can't keep up with the demands of our hundreds or thousands of pulls when our software is deploying. So that was a short short-sighted view of that, and so we're working on transitioning to using ECR, which can scale and actually works pretty well. That's an AWS service if you're not familiar with that. That's a Elastic Container Repository, I think. That sounds right.
Correct.
Oh yeah, here we go. Even more advanced. Yeah, it goes off the bottom of the screen there. So yeah, you're probably going to deploy your software to lots of places. Maybe maybe CrowdStrike millions of places. Just make sure it doesn't blue screen everybody. Docker. If you're not familiar with Docker, Docker's a container manager. It's a I'll call it a virtualization tool. I think that's an accurate statement. Not VMs, but a way of a mechanism for virtualization. Images are, think of them like templates for containers. When you build an image, the image isn't runnable, but it goes and deploys out as a container, and then your software exists out on the host that's running the container. Containers are great. If you're not familiar with Docker, learn it. It's not going away, or at least containerization is not going away anytime soon. Very useful. It's probably about 10 years now. It's really been taken over as like the way to run software, specifically when you have a bit of software that's totally self-contained and you need it to run in a lot of places, like a little web server or something like that. Very useful. But Docker itself has the mechanisms built in to do packaging, distribution, installation, and deployment, and managing of all that. And then there's lots of other tools out there that build on top of that, like Kubernetes, or I'm pretty sure like Slurm. Some of those others will just take Docker containers and go run them. Mesos. But something to consider when you're building a Docker container. You run these Docker files. It's got to go get that software from somewhere. You could have your software baseline on your computer that you're building, and then you're packaging it up. But I found that it's really more useful if you've already distributed that software to a Nexus repository, to then use Nexus to use your Docker file and use Nexus to then pull that software into a Docker container to build your image. It makes for much cleaner and easier builds, especially when things fail along the way and you need to restart at a point. You want to be able to start at the Docker build and just go grab that jar file or grab the Python wheel file, whatever that looks like. And so you end up with this kind of a recursive process of this CMDID process, where you can build you build your Java, you package your Java, you've done your unit test, you send it to Nexus, but then you need to package your Docker image, and then you're going to distribute to your Docker registry, then you're going to install your Docker image and then deploy your container. But then it goes further, because you may have libraries dependent on libraries. So you build your Java, you test it, you distribute it, then you build your next Java project, because maybe you've got a team of 50 developers that are developing hundreds of libraries that need to all be tied together. And so you end up with these really complex processes, but you can break it all the way down into these individual chunks, because especially when you're developing hundreds of libraries across teams, like it's gonna fail often. Like things are gonna break along the way, and you need to be able to identify where they broke, and optimally you'll be able to start right from where it broke and continue on it, because those processes, no matter how fast you make your unit tests and your packaging and all that, when you're talking those kind of scales, it's time consuming. Like best case scenario, you're spending like half an hour deploying these things, but I've had cases, of course,
1 hour later.
Yeah, it's hours. It can be hours to get through this process, which can be really frustrating when you're up against a deadline.
Hey, Robbie.
So, yeah.
Quick question about this. We all obviously get that you know what you're talking about. I'm not questioning that. I already knew you knew what you were talking about. But what's the scale of this? Like, I know you're talking about like some guys have probably worked on teams of like 5 or 10. Some of this stuff you're doing this with like hundreds of engineers, right? In on some of this, right?
Yeah, I think the biggest development, actual software developers on a team was probably around the 75 mark. But yeah, as far as engineers, people that were involved, integration test engineers, systems engineers, into the hundreds. Yeah, we're talking big scale at this level. So if you're on a team of 2 to 3, your whole your CI/CD process might be a collection of a couple of scripts and run from Jenkins. But you may be on a team where you've got 10 people that manage one of these boxes, one of these libraries, and you want to keep those isolated. So yeah, that is an important distinction, and I'm glad you brought that up, Scott, because you don't want to over engineer something that can be simple, but sometimes you need this when you're managing an enormous engineering team, and not just managing it, you're managing a process with a big team. And to be clear, this process, while we had 75 developers, this process was managed by 3, really, well, I guess including some of our other team, maybe like five integration software engineers. Yeah, the 2 pizza team concept, that is very important. When you're actually developing software, you want to keep the teams small, which this helps, because I can have a team developing a library that is used down the chain, and they can be totally independent. They got their own tests, they got their own unit tests. Maybe they even have some level of integration tests that can release their own code before it makes it down to the next line. So yeah, very important to think about that, particularly when you have a really big program. Because when I say we had 75 developers, that wasn't on one team. That was one program. It was probably split across 10 teams. You're welcome to ask questions. That slide was there, but it was there because that was the end of a presentation at another time. Well, we got 15 minutes left, and I'm on my last set of slides, so perfect. This is just kind of talking about initial checkouts, back to testing, and some recap. Oh, I like this because it makes me mad at Python. So that's a little hint. What are the contents of A, B, and C at the end? Like if I put at the end print A, print B, print C. What do you guys think?
I know.
I think if I wait long enough, you'll tell me.
I think you're right. You are right.
Oh, you meant my thoughts on this? Yes.
Yeah. Bonus. Well, I mean, if you know the answer, you know why. But if you could say why. All right. OU Moon has a guess in there.
Some of these guys are legit software engineers, so they probably know this way better than I would.
All right. So Salty's got a guess in there. OU Moon is right as far as it's about Python reusing the same list. I'll give us maybe 15 more seconds, and I'll reveal the answer.
Oh, you're gonna reveal it.
I don't actually know if I have it in the slides, so we'll see if I'm really right.
I like it.
That's fair. Last chain. Yeah, nobody's got it right yet. Oh, Salty, you're kind of close, kind of, but not really. You're way off. Nope. All right. Here we go. So if you were to print these out at the end, A would be I'll give it, well, it would be a list of two values. A would be bar bar. That should break your brain for a second. B will be I believe it's Baz bar. I might have got that reversed, but anyway, it's Baz bar. And then C equals A, it will be bar bar. So somebody said A equals C, which you're right, but the actual values were off a little bit. And so the reason this is just down to the developer, like the strangeness of Python, it comes down to this right here, the initialization. This is actually a pointer. So right now we're saying A equals a pointer to this list. And so what happens is I call this here, and A, this little a, adds bar to the list. And so A at this point right now is just a list with bar in it. That makes sense, right? It just started with a blank list, got bar. B, we come down here and we pass in Baz here. And so now, okay, well, we're not using this anymore. We're not using the default. I'm passing in Baz and I'm going to add bar to it. So I believe that really ends up being Baz bar. So B at this point is Baz bar. And then C, we say, well, no, let's go back to using the default. Run this. I want you to add bar to the default, except when we ran A, we added bar to the default pointer of bar. So yep, you got it right there. A, B, and C at the end is our bar bar, Baz bar, and bar bar, because Python, this is really a pointer off into the memory, and it's forever this list, not an empty list. It's forever the reference of this list. So when you run C, you're actually just adding bar again to that same list. That's bitten me before. Don't do this. Anyway, the more you know for Python programming, don't do this. All right, yeah, so here it is. Configuration management, build and unit testing, package, distribute, install, deploy, and initial checkout. So initial checkout, it could be a number of things. It could be health checks. It could be interface checks, smoke tests to make sure, right, doesn't, when you run an exercise, it doesn't release the magic smoke. It could be system verification, which is BDDs I was talking about. That could be a full suite of tests to make sure the software is meeting your specifications or meeting the requirements it needs to meet. But that's your checkout to make sure that that your software is ready to go, your system is ready to go. And it can be a bunch of different ways, right? You could just log into a system and make sure that it's good to go. I wouldn't recommend that in an automated suite. You don't want a person in the loop, but you could. This process actually wasn't developed originally for full automation. I just found, like, holy cow, this answers all the things I need to do this fully automated. But it originally had a lot of manual steps in it. But you could be writing scripts to do these checks. It could be jobs in Jenkins or GitLab runners checking things. They could be you could be looking at a dashboard on like a Nagios screen to make sure everything's still green. There's so many ways you could do this. It could be a variety of these mechanisms. But some examples of where you might see this checkout. If you've ever installed WordPress, it does this for you. When you're putting in your database credentials, it's checking to make sure that they really work. When you're done with the installation, it it creates like default users and first blog posts, and those are all to verify that everything actually works, right? Because if you go in there and the first blog post isn't showing up, that means something is wrong with maybe something happened with your post table, and you can go dive into that. In video games, the first thing you might go in to some of the validation where it's testing frame rates and GPU settings. Sometimes there's separate utilities for that in games, or sometimes it really is just like the launch animation or something is testing those. So that's checkout. So on all the way back, building unit tests is occurring for us on a Jenkins agent. It compiles the code, executes unit tests, fails if either of those don't work. If they pass, then we're packaging them up and we're sending them off to another host, our Nexus server, or depending on the software, NFS server, or posting it to S3, any of those things. Then we're installing it, which is actually taking that from the repository, from the artifact repository, to place it on the target server, target host, where the software is actually going to run. In the something I didn't say earlier, but that could be setting up Lambda functions or in serverless functions in AWS. You probably would have packaged the software in a zip, put it onto S3, and now you're setting up the Lambda function to point to that S3 zip location. That's a little bit of a hybrid. That maybe that's an install, maybe that's a deployment, depending on how you're setting up that Lambda function.
Hey, Robbie.
Yeah.
Hey, I asked this earlier, but you probably missed it. I was actually asking because I know you do quite a bit with AWS, even though this topic wasn't AWS. How do you find code pipeline fits in with a lot of this methodology? Are there any gaps in that you have to put in another tool, or is this working pretty well? Have you tried code pipeline?
I have tried code pipeline. We don't use code pipeline because in the systems that we're on, we don't necessarily have all the utilities that make it useful.
Okay.
That has to do with the government systems we support. But it should be telling too. We work with AWS, and they use GitLab. So go figure. We may even have. Do we have somebody that supports AWS here?
You don't. 2 guys here and tomorrow.
You don't have to reveal the secrets, but I know the team that I work with. They use GitLab. They don't use the AWS tooling. Interestingly, they prefer it. Maybe that's just that team. I don't know.
You can't tell how the biscuits are made, Robbie.
Yeah.
They're blowing you.
Right. We are in that separate ecosystem specifically, so we can use that on our partnership there with AWS. Anyway, I won't get too in the weeds there. I don't want to throw you guys under the bus. So deployment. This occurs on the host where you're running the software, or I should say the deployment occurs where you're running the software. That is where the software is running. You may execute a script that tells the software to start externally, but ultimately the software that should be obvious. It's running on the server that you want it to run on. So a Jenkins agent may trigger the deployment, and that could be that there's a Jenkins agent on the host that you're running the software, or it could be that Jenkins agent is SSHing to a host and starting it, or using Kubernetes functions to start pods, something like that. And then ICO occurs where the software is accessible, right? This could be anywhere. Of course, the software is running on your target server, on your host, but you don't have to run the ICO script on that host. It could be on Jenkins hitting REST endpoints on that target server to make sure things are good, or if you have if you've got Selenium for UI testing. I didn't even mention that earlier, but if you're doing UI testing, you probably don't even want to you want to make sure you're not on the host where you're running the software, because you want to make sure it's accessible externally. If you're hosting something out on the internet, you probably want to run your tests from a host that isn't connected to that server on the same network. You want to be able to access it through the internet to make sure those connections are getting made correctly. And I think I've reached the end. Whoa, that was like perfect timing. 3 minutes for questions. I know I don't know that we have anybody after me, so time for questions.
Well, there was nobody after you, but Salty wants to do a bonus round, so you got half an hour, and then we'll do that. But no, that's perfect. What questions you guys got for him? Some of them talked to you like 6 weeks ago or so, though. So some of them kind of got to talk to you a little. But yeah, what do you guys got?
I just want to jump in real quick and say this was a fantastic talk. This is the only one I was able to see so far. But to hear what you're saying come from the DevOps side, as opposed to the development side, it's really eye-opening. So yeah, this was great. Thank you.
Awesome. Thank you.
Man, that was a great talk, Ray. Like, I love that entire thing. I love the problem space you're working in. But primarily, I'd love to find out more about getting people into